this video, we're going to look at trigonometric identities. These are identities using or that involve trigonometric functions. We're also going to introduce some new trigonometric functions that we haven't seen in any videos in this series so far. So far we've looked at sine, cos, and tan. We're going to use these to define some new trigonometric functions. Now, by identity, we just mean an equation that holds for all values. Because remember, sine, cos, and tan, they're functions, so you can put different values into them. You'll get different values out. But there are certain equations that are always true, regardless of which values we put in. And we call these identities. So one very important one, which you may have seen before, is that sine squared of x plus cos squared of x equals 1. So again, we can put any value for x in here, and this will always be true. So any number whatsoever, if we take the sine of it and the cos of it, we square them and we add them up, we always get 1. So this is very important identity. We're going to put it here in this box. And now we're going to define a few new trigonometric functions. So these aren't going to be identities, what we're going to say now. They're really just definitions. So we're going to define sec of x is equal to 1 over cos of x. So don't worry too much about this. If you've not seen it before, hopefully you have, but if you haven't, you just have to remember that the sec of x, which is short for the secant of x, is 1 over the cosine of x. And then similarly, we define cosec of x. So we write it CSC for short, but we say cosec of x equals 1 over the sine of x. So cosec is short for the cosecant of x. So you've got the secant of x and the cosecant of x, which we say cosec, and we write CSC. And finally, the cot of x, so COT, the cot of x, is 1 over tan of x, or 1 over the tangent of x, and cot is short for cotangent. So if you've not seen these before, it might just be worth even pausing the video and writing them down or trying to remember them. You've got sec of x is 1 over cos of x, cosec of x is 1 over sine x, and cot of x is 1 over tan x. So we're going to use these functions and the identity at the top to solve a few problems. So let's look at example 1. Prove that 1 plus tan squared of x equals sec squared of x. So we only need the information in the left-hand boxes to do this. So let's just start. So we want to start with 1 plus tan squared of x, and we want to somehow rewrite it until we end up with sec squared of x. So what can we say? Well, hopefully you know that one definition of tan, or the definition of tan, is that it's sine over cos. So tan x equals sine x over cos x. If you don't know this, again, you should make sure you remember this, but that's what tan is defined to be. It's sine of x over cos of x. We don't often need to know this, but in this case we do. So 1 plus tan squared of x is 1 plus sine squared of x over cos squared of x. Now we have two separate numbers being added up. One's a fraction, so really if we write them both as fractions with a common denominator, we can combine them into one single fraction. So we essentially want to write 1 as a fraction such that its denominator is cos squared of x. That's very easy to do. You just write it as cos squared of x over cos squared of x. So anything divided by itself is 1. So we've rewritten 1 so that it's a fraction with the same denominator as our other term here. So we have cos squared of x over cos squared of x, that's just 1, plus sine squared of x over cos squared of x. Now hopefully you understand that with adding up fractions, once we've got a common denominator, we can just add up the numerators, so what's on the top, and write them over that common denominator. So we have that this equals cos squared of x plus sine squared of x over cos squared of x. So we have the two numerators added up over the common denominator. And now this is where we use our identity. See, on the top we have cos squared of x plus sine squared of x, and that's just 1 by our identity. So we have 1 over cos squared of x. So I've just used that equation in the top left-hand box. Now 1 over cos squared of x, well, you could think of that as 1 over cos of x all squared. because if you did square 1 over cos of x, you'd square the top and the bottom. 1 squared is just 1. The bottom squared would be cos squared, so you get 1 over cos squared of x. So essentially I'm saying this is just sec squared. It's 1 over cos squared. 1 over cos is sec by just definition, again on the left hand side. And so we're done. We've started with 1 plus tan squared of x, and we've shown that it's equal to sec squared of x, which is exactly what we wanted to do. So this is a relatively short mathematical proof. Good to make sure you understand each step here. You can always go back in the video, rewatch it if you didn't understand, pause it, make sure you fully understand what I've done. And we're going to try one more example, which is very similar. So if you understood the first one, hopefully this one's not so bad. So prove that 1 plus cot squared of x equals cosec squared of x. So again, we'll start with the left-hand side, 1 plus cot squared. And we will say that this is equal to 1 plus 1 over tan squared. Again, that's just from the definition of cot. We can see on the left-hand side it equals 1 over tan. So 1 plus cot squared of x is 1 plus 1 over tan squared of x. We'll now once again use the definition of tan as sine x over cos x. So we have 1 plus 1 over sine squared x over cos squared x. This is starting to look a little messy, but don't worry about it. So let's try and rewrite this second term so it's a bit neater. We're dividing by a fraction. We've got 1 divided by a fraction. Now, whenever you divide by a fraction, you just flip the fraction over and times by it. So in this case, we have 1 divided by sine squared over cos squared. We flip that over and times by it, we get 1 times cos squared over sine squared. Now, if you times anything by 1, you don't change it. So 1 times cos squared of x over sine squared of x is just cos squared of x over sine squared of x. So we get 1 plus cos squared of x over sine squared of x. So we've kept the 1 at the beginning, and we've just then rewritten the second term to make it a bit neater. So we end up with 1 plus cos squared of x over sine squared of x. Once again, we do exactly what we did in the last problem, and we rewrite 1 as sine squared of x over sine squared of x. And we get sine squared of x over sine squared of x plus cos squared of x over sine squared of x. We do this to get a common denominator so we can add these two things up. We get sine squared of x plus cos squared of x over sine squared of x, our common denominator. And once again, we use our identity. We have again got sine squared of x plus cos squared of x in the numerator, which we know is just 1. So we get 1 over sine squared of x. Let's look at our definitions. 1 over sine x is cosec x, so 1 over sine squared x is cosec squared x, which is exactly what we wanted. So there you go. Using our trigonometric identity, which is a very common trigonometric identity, and these definitions, we've done a few relatively straightforward proofs.
Music in it, as she had never